Good afternoon, class. We are looking at the final exam. Final exam covers the entire thing from 2.1 to 6.1, and there's the second part covering chapters 3, 5. Again, I want to remind you about this pledge. I can't emphasize the importance of understanding the fact that when you take the exam, it makes no difference whether you take it online or on campus. Okay, you cannot give or receive assistance. End of the story. Okay. And I hope everybody is following that. All right, let's look at this example. Observations show that the length L in millimeters from nose to tail of a Siberian tiger can be estimated by the function L equals 0.25 W to the power of 2.6, where W is the weight of the tiger in kilograms. Furthermore, a young tiger's weight can be estimated in terms of its age t in days by the function W equals 3 plus 0.21 t. How long is the tiger when it's 100 days? A couple of different ways to approach this. We're going to look at both methods. First and foremost, t is equal to 100. So we are going to replace it here. This becomes 21, and 3 is 24 kilograms. Length is a function of the weight, so plug in W equals 24 into this. Raise it to the power of 2.6 times the 0.25 and 969.369 millimeters. You have to go with a bunch of decimals, and eventually you round it accordingly. So this was elementary algebra. At what rate is the length increasing when it's 100 days old? The moment you see rate and 1 point in time, that means differentiation. And as far as the Leibniz's notation, dy dt is dy du du dt. And in this case, rate with respect to time, it happened to be in days, so we want dl dt. And I'm going to write it in this fashion, and I'm going to remind you, there's an intermediate variable as we go from L to T. What's in between? It's W. So dl dw dw dt. So we're going to take this and differentiate it with respect to the independent variable W, which becomes 0.25 times 2.6 W to the power of 1.6. And then times dw dt, the derivative of this guy is just 0.21. The product of these three numbers, we put it in front. Now, you could replace the W with 3 plus 0.21 t if in case you want a function of t. However, since we are interested in finding the rate when it's 100 days old, and at that point, when it's 100 days old, the weight is 24, you can replace it accordingly. And again, you get the answer with perhaps a couple of decimals, 22.0532. Now, units of the length over the units of the time, millimeters per day. Now, that's pretty straightforward, everybody. I want to look at the second methodology, meaning this is easy to find the composite function, replacing the W with 3 plus 0.21 t. L becomes a function of t, and work on that. You can do that. Okay, so obviously L for part A, t is 100, replace it, and if you go through the process, you will get the same answer as here. And again, as far as the number of decimals, you want to pay attention to the number of decimals that they ask you. Now, to differentiate the L dt or L prime of t, you do the chain rule. So 0.25 remains times 2.6, the same thing to the power of 2.6 minus 1, which makes it 1.6 times the derivative of the inside, which is 0.21. One more time, this one remains. 2.6 sits in front, the same thing to the power of 2.6 minus 1. The derivative of the inside is 0.21. These three numbers give you the same number here. And I hope you see that if right here we change the W, we would have got the same thing. And of course, L prime of 100 is the same answer as we had here. So it's pretty straightforward, everybody. Again, you're looking at the examples we have seen. I just quickly go over them to refresh your memory. Find an equation of a tangent. And in short, you need two things. You need a pair which is given 0, 1, and you need the derivative. To find the derivative, you differentiate, and you differentiate in this case implicitly. This is x times e to the power of y. You put a raised dot, and you use the product rule on this, f prime g plus g prime f. So f prime is 1 times e to the power of y plus g prime. E to the power of y is itself. The exponential function is always itself. And remember, y is like g of x, so times g prime, in this case, times y prime, and then times f, which is x. Same thing here. We put a raised dot here, and this is again fg. So the derivative of the y is y prime times the second one, e to the power of x. E to the power of x is itself times y, and of course, any number results in 0. Right now, you can plug in, and everything is given. You find y prime. When you plug in, becomes a slope. However, let's solve for y prime, which means we are going to keep these two because they have y prime, and this goes to the other side, becomes negative. This goes to the other side, becomes negative. So both of them are negative now, and these two, if you factor them, you can take the y prime out. You get e to the power of y times x, and this one is e to the power of x. So this one divided by the parentheses is y prime. What is the slope? Plug in, which means replace the x with 0, y with 1. Now, e to the power of 1 is e to the power of 0 is 1. So this is 1. So what we are looking at is the numerator is e plus 1, the bottom is 1, and the negative sign in front remains. So simply changes it to minus e minus 1. And because this is the y-intercept, you can write y equals mx plus b. So y is m, which is this, mx plus 1, and that's the exact answer. And again, I can't emphasize this enough in calculus. E is E, ln 5 is ln 5, and so on. Make sure you follow that. Differentiate e to the power of 2x times ln x. Again, to differentiate, we notice this requires the product rule. We put a raised dot in between, and we say f times g, and we use the product rule. F prime is any exponential is itself times 2, then times ln x, plus ln x gives you 1 over x times e to the power of 2x. Done with calculus. If you factor this out, you get 2 ln x here, 1 over x here, and you're done. The very first thing is to decompose the log when you want to differentiate it. That's the fastest way, and it can't be decomposed anymore. So the moment you see a log, you flip it over. 1 over x squared plus. Then by the chain rule, you need the derivative of the argument, which is 2x. And when you look at the base, if it's e, we are done. If not, 1 over natural log. So 1 over ln b, 1 over ln 5, and you rewrite it. What about this one? Definitely we decompose that. ln of the top over ln of the bottom. We are looking at number 6. So ln of 2x minus ln of 2x plus 1. And ln of 2x is ln of 2 plus ln of x 5. So this is 1, everybody. Now we are going to differentiate. Needless to say, ln2 is a number. The derivative is 0. ln x is 1 over x. So this is 0. This is 1 over x minus. Flip this over. So keep the negative sign. Flip this over. Minus 1 over 2x plus 1. And by the chain rule times the derivative of the inside, which is 2. Done with calculus, we are going to take a common denominator, which is x times 2x plus 1. And this gives you 1 times 2x plus 1. And this gives you minus 2 times x. 1 times 2x plus 1 minus 2 times x. We have 2x plus 1 minus 2x. 2x and minus 2x cancel each other. And the final answer is 1 over x times 2x plus 1. That is the final answer, everybody. Logarithmic differentiation, y equals x to the power of sine x. First of all, even if they don't mention it, class, when you have a function to the power of function, that is the best course of action, although you can use the exponential format also to do it. But what is logarithmic differentiation? Let's remind everybody. Number one, take natural log of both sides. So we're going to take the natural log of both sides. So what happens is that the right side sine x sits in front. We are looking at number 7, the power rule. So the left side doesn't change. Number 2, differentiate implicitly with respect to the independent variable happen to be x. So ln y gives you 1 over y times y prime. That's the left side. The right side clearly uses the product rule. So let's just write f times g f prime is cosine x times g, which is ln x, plus ln x is 1 over x times f, which is sine x. Finally, solve for y prime or dy dx. To solve for this, that means you multiply both sides by y. So in other words, 1 over y, take it to the other side means multiplied by y. And when you multiply it by y, you have to replace it with x to the power of sine x. You must do that. Of course, this is cosine x ln x is 1 over x sine x. So it's very straightforward. And as I mentioned, it is important to be done in that fashion. Now, there is a second method. Remember that e to the power of ln x is x. And since y is x to the power of sine x, we can replace the x with e to the power of ln x. Now, e to the power of ln x to the power of sine x means e to the power of ln x sine x. And now you can work on this and that will result in the same thing. Again, this is logarithmic differentiation. This is using exponential rules to write it as e to the power of ln x times sine x. And you know the derivative of exponential is itself, and then times the derivative of ln x times sine x. And remember, that's exactly what happens here. You take the derivative of this one, and then you multiply it by y, and this is the same. That ends up giving you the same answer. So that's a different methodology, very similar. Differentiate y equals x, sine inverse of 3x. And so immediately let's put a raised dot here and make it product. So x, the derivative is 1, times whatever the g is, sine inverse of 3x. And then sine inverse, remember the derivative of sine inverse is 1 over square root of 1 minus x squared. If it happened to be a function, then you have to figure this out. Instead of x here, we're going to use the function 3x. And instead of 1, remember 1 is the derivative of x, you're going to put du dx. That's why you really use this formula. So this is the formula in essence that you are going to use on this one, which means one way to write this, write it in this fashion. Okay, the top is something square root of 1 minus something squared. Okay, and so what you're looking at here, okay, this is du dx. So this is the u we are talking about. So you need 3 here, 1 minus, you need 3x quantity squared, and times, so this one is g prime, and now f, which is x. In other words, let me write f prime g plus g prime f. And so we rewrite this. Obviously, this is simply sine inverse of 3x. And this one, you have the 3x at top, square root of 1 minus 9x squared. It's very important not to leave this in this format. You really have to change it to 1 minus 9x squared. As far as I'm concerned, if you write 1 minus 3x quantity squared, you're not done. So what happens here is we are going to put a raised dot here and use a product rule on that. And this is 1 minus x squared to the power 1/2. So we make it ready to use the extended power rule. So starting with this one, x gives you 1 times cosine inverse. And remember, the derivative of cosine inverse is just like sine inverse, but you have the negative 1 at top. So in other words, the same thing here, this one is negative. So minus 1 over the square root of 1 minus x squared, and then times x. So right here, let me put this down as f prime g plus g prime f. And now let's work on this. So 1/2, so minus 1/2 times the same thing, 1 minus x squared to the power of 1/2 minus 1, which makes a negative 1/2, and times the derivative of the inside by the chain rule, which is negative 2x. And that's the only calculus step. So this one is just cosine inverse. This one minus x, okay, minus x over square root of 1 minus x squared. This one is plus x over 1 minus x squared. So again, I hope you can see that negative 2 cancels out 1/2 and negative makes it plus. X is at top, this goes at the bottom with the positive 1/2 as the exponent, which becomes a square. So these two cancel each other. The final answer is cosine inverse of x. The distance in meters of an object from a starting point is given by s of t equals 2t squared minus 5t plus 40, where t is time in seconds. What is the velocity of the object from 2 to 4 seconds? That's just the average velocity. Just plug in 4 and then plug in 2 and then t2 minus t1, 4 minus 2. It's a simple case of finding the average velocity total distance, s of 4 minus s of 2 over total time, 4 minus 2. You plug in and you end up with 7 meters per second, units of the numerator over the units of the denominator. So that's pretty straightforward. What is the instantaneous velocity and acceleration of the object? What is the velocity and the acceleration after 6 seconds? Well, velocity, you take the derivative of this. You get 4t minus 5. And after 6 seconds, you plug in 4 times 6 minus 5, which gives us 19 meters per second. Even if they don't mention instantaneous, one point in time, that's what it means. What is acceleration? Acceleration is the second derivative of the position function. A of t is v prime or s double prime. So you differentiate this again, which gives you 4. I'm going to discuss the units in a moment, but what matters is that it becomes independent of t. So whether it's at 6 seconds or 5 seconds or 10 seconds makes no difference. The units for A follows, if you write it in this format, dv dt, change in velocity, meters per second over change in time. And that's why we get 4 meters per square second as the unit. What does the object, when does the object reach the velocity of 31? So set the velocity 4t minus 5 equals 31. Minus 5 goes to the other side, becomes positive. 36 divided by 4 is 9 seconds. A 180-degree turkey is removed from the oven and placed in a 74 degrees Fahrenheit room. After 15 minutes, it has cooled down to 136 degrees Fahrenheit. Find the general solution for it. Even if they don't ask you for that, I highly recommend that is what I'm expecting. Find the general solution and then move on to the next step. And to do that, reminding everyone that the capital T, which represents the temperature, lowercase t, which represents the time, is y sub 0 e to the power of kt plus t sub s. We've gone through that, okay? And t sub s is the surrounding temperature. Y sub 0 becomes t sub 0 minus t sub s as a result. So what is t sub 0? The very first number is the initial value. T sub 0 is 180 degrees. So the temperature is at 180 degrees to begin with. When we bring it to the room temperature is the surrounding temperature. T sub s is this much. And then after 15 minutes, capital T of 15 minutes is this much, 136 degrees Fahrenheit. So what I have here is writing the same thing, but symbolically, so we can use it. Now, y sub 0 is t sub 0 minus t sub s. The difference between the two is y sub 0. And all you have to do, you can even plug it in to see if you replace the t with 0, you get that anyways. So 180 minus 74, 106. So we will replace that. We have y sub 0. as 106. We have T sub S as 74. So that's the formula. And I hope you see that if we have K, practically we have everything. So to find K, we use the fact that T of 15 is 136. So if I replace the lowercase t with 15 here, then capital T becomes 136 degrees. So T of 15 is 136. So T of 15, 106, e to the power of K times 15 plus 74 equals 136. So subtract 74, you get 62. Divide by 106. And again, on purpose, I'm not simplifying this because I want you to see where every number comes from. Take a natural log. Why natural log? Because the base is e here. So the left side becomes 15k. And so k is the right side divided by 15. And this is an exact answer. Now you put it into a calculator with a bunch of decimals, you get this number. And so T of T, everybody, we have everything now. K is replaced, and that's the general solution. Now, I want to show you quickly a slightly different methodology. Okay, so over here we have 62 over 106 or 31 over 53. And so if I raise this one to the power of 1 over 15 and this one to the power of 1 over 15, the left side becomes e to the power of k. So 31 over 53 to the power of 1 over 15. And since this is kt, then all I have to do, raise this to the power of t, which means multiply the exponent by t. So e to the power of kt is the same thing to the power of t, which makes it t over 15. So you could write this one, instead of e to the power of kt, would be 31 over 53 to the power of t over 15. That's another way of writing it. The difference is actually this is a little bit more precise because over here we use the calculator. Okay, just to let you know in case you go with that. Now we are looking at the same thing. Part B, we are looking at the same thing. We have both answers here. Now, what is the Turkish temperature after 16 minutes? To be honest with you, if you use this one, it goes pretty easier because 60 is divisible by 15. So replace this T with 60, okay? So, of course, at this point, raise this one to the power of 4 times 106 plus 74. And then you have to put it into a calculator. It gives you this answer, 86.4065. I put a bunch of decimals. Normally, they don't go with that many decimals. Normally, they go with, this has no decimals. They go only with one decimal. But you have to pay attention to what they want. So how long will it take for the turkey to cool down to 110 degrees? You can use this one or that one and set it equal to 110. Either way, you come up with an answer very similar to that. So obviously, the first thing is to get rid of 74. You get 36. And you're going to divide by 106. So you get this one. And since the base is e, you're going to take a natural log of both sides. The left side They cancel each other. You just get the exponent, and you have this one. And t is the right side divided by the coefficient of t, which is negative 0.0357554. You really have to carry a lot of decimals for intermediate steps. It is at the end that you may do the rounding, so about 30.2, about 30 minutes, okay? But in between, you want to carry out a lot of decimals to be on the safe side. A small rock is dropped into a lake. Circular ripples spread over the surface, with the radius of each circle increasing at a rate of 3.5 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet. All right, so what do we need to know? Of course, a circle looks like that. From the center to the circle is the radius. Go both sides the diameter. These two arcs. The circumference C is 2 pi r. A equals pi r squared. We need the area. So area is pi r squared. Radius is increasing at this rate. That means the RDT is 3/2 feet per second. What do we want? The ADT at what point r equals 4? So this is the translation of the question. Okay, everybody, this is the translation of the question in mathematical symbol. And so if A is pi r squared, the ADT is pi times, now you want to take the derivative of r squared, you get 2r, because with respect to the time you're interested is 2r dr dt. Okay, so that means t is the independent variable, not r. That's why you get 2r times dr dt, which makes it 2 pi r dr dt. And all you have to do, plug in, replace the r, replace the dr dt, and keep the pi intact. These two cancels out. You get 12 pi. 12 pi square feet per second, and this is the rough estimate. Always, always have the exact answer and report it with the exact answer unless they ask you for an approximation. I want to find dy dt in this case. Needless to say, the moment you see dy dt, what is the independent variable t? So to differentiate this, we're going to use the extended power rule 4 times the same thing cubed. But now the derivative of 5x and y, this is 5 dx dt, this is dy dt, and that's what I mean. Pay attention to the independent variable. And so minus x minus dx dt, and any number results in 0, you are done. Now, granted, we can solve for dy dt, but we can also plug in. So let me move on, just plug in, everybody. Plug in the information that has been given to you. So this is 1, cubed is 1, so you have 4, and this is 15. And 4 times 15 is 60. This is 4 dy dt minus 3. 60 and negative 3 is 57. Move it to the other side. Minus 57 divided by 4 is the final answer. A 20-foot ladder leans against a building. The base of the ladder slips away at a rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. So a 20-foot ladder leans against the building. So this is the building or the wall. This is the ladder. The base of the ladder slips away this way, which this, since we call this x, this makes it dx dt 2 feet per minute. So it's coming down this way, creating this shape, which is a right triangle with this coming down, creating dy dt, and that's what we are looking for. And the ladder is fixed. It doesn't change the size. So it's 20 feet. So it uses Pythagorean theorem that says a squared plus b squared equals c squared. In this case is x squared plus y squared equals c squared or 20 squared. Dx dt is 2 feet per minute. Dy dt we are interested in when the base x is 12 feet. So that is the translation of this. Again, what I want to emphasize, there is no way for anyone to write this without this drawing defining variables. If you don't have this drawing, x, y, dx dt, dy dt, see, this is meaningless. Okay? Because nobody knows which one is x, which one is y. You must have a drawing. Now this is 2x dx dt, this is 2y dy dt, this is 400, which results in 0 because it's a number. Now you got everything except y is missing, so you go back to this one, replace the x with 12. 12 squared is 144. 20 squared is 400. Subtract from 400, you get 256, take a root, becomes 16, and now you got everything plug in, and it gives you dy dt. Which is negative 3/2 feet per minute. As I've mentioned it always, x is increasing, dx dt is positive, y is x is increasing, dx dt is positive. Y is decreasing, dy dt must be negative, and it is. Falling sand is forming a cone-shaped pile. The volume of the cone is increasing at a rate of 54 pi cubic inches per minute. The height of the cone is twice the radius of the base. Find the rate at which the radius changes when the radius is 6 inches. Again, I need the drawing. I want the reader to understand. Here's the cone shape. Here's the radius of the base. Here's the height of the cone. And since we are dealing with the volume, I should know the volume is 1/3 pi r squared h. That's a piece of information we should have. So now the volume is 1/3 pi r squared h. The volume of a cone is increasing at this rate. This means dV dt is this. dV dt is 54 pi cubic inches per minute. Height, twice the radius. H is 2r. H is 2r. What are we looking for? Find the rate at which the radius changes, dr dt. At what point? When the radius is 6. Now, again, we have the drawing, we have the variables, and we are translating this into mathematical symbols. Now, we have two variables here, r and h. To make it into one variable, we use the fact h equals 2r. So we are going to replace the h. By the way, depending upon what you want, because you want dr dt, you want to make this a function of r. If the question was dh dt, then you would replace the r. R is h over 2, by the way. So in any event, you rewrite this, and now you're going to work on this. You want dv dt, which is 2/3 pi, times, now you work on r cubed, which is 3r squared dr dt. This 3 cancels out this 3, and you write 2 pi r squared dr dt. So what is dv dt? 54 pi. What is r? 6. What is dr dt? That's what we are looking for. So you put everything in and find the missing one. Or you may say dr dt is dv dt divided by 2 power. So it doesn't matter. It works out the same way. 6 squared is 36 times 2 is 72. So you have 72 pi. And you're going to divide both sides by 72 pi. Obviously, these two cancel each other. Both of these numbers are divisible by 18, 3 over 4. So 3 over 4 inches per minute, dr dt. The units of radius over the units of time. The units work in the same manner. Use differential to approximate the square root of 27. First, we need a function. What function? All you have to do, read this square root. So you need square root of x. And then you need a number. Choose a number x close to 27 for which the square root is easy to compute. Obviously, it's 25 because we should know square root of 25 is 5. So we want to go from 25 to 27. So 27 minus 25 is dx or delta x, which is positive 2. It's important to understand. It's positive 2. If you want, again, square root of 24, dx would be negative 1. I've mentioned that a number of times by now. And so f of x plus delta x is f of x plus dy. We are using this approximation where f of x is square root of x, but dy is missing. To find dy, we are going to differentiate this first. We are going to write it as x to the power 1/2. And we know the derivative is 1/2 x to the power of negative 1/2 or 1 over 2 square root of x, which makes dy the same thing times dx. And now we are going to rewrite it in this fashion, okay? So we want square root of 27, which means f of 27, which means f of 25 plus 2, which means over here, x is replaced by 25, dx by 2. So this is 5, this is 5. So these two and these two cancel each other, 5 and 1 over 5, or 5 and 1/5, or 5.2, and we are done. As far as the closeness, if you look at the calculator value, this is very close to what you have here. Okay, within 2 decimals, they're the same. Okay. All right. So the second methodology I want to look at, so what you looked at is the differential. If we find the equation of a tangent line for this guy, that is also known as linearization, everybody. Which means I need to find the tangent line L of x for this function f of x equals square root of x at the number that we picked here, x equals 25. That's the meaning of it. So we need a pair. A pair is simply 25, plug in 5, 25 comma 5, and we need the slope. To find the slope, we go with the derivative. If I plug in 25 here, I get 5 times 2 is 10, so 1 over 10. So now we are in business. Y minus y1. So you don't have to memorize this. And I say a lot of people do that. I don't know if they really have memorized it or not. So you don't have to. Y minus y1, so y minus 5 equals m 1 over 10, x minus x of 1, that means x minus 25. And you end up with the following, which means if I replace the x with 27, and you can try it, I should get exactly what I got here with the differential. All right, let's differentiate the ddx of sinh 10x squared, reminding everybody the derivative of sinh is cosh, the derivative of cosh is sinh, and so forth. Now, with that being the case, what is the derivative of sinh u? It's cosh u du dx by the chain rule. So sinh becomes cosh. So cosh of what? Absolutely the same thing, 10x squared. And then because this is a function of x by the chain rule, du dx, we need 20x. We put it in front and we're done. So we rewrite. What is the derivative of cosh square root of x? The same thing. The derivative of cosh is sinh. Okay, so you can write sinh. Sinh of what? The same thing, because it needs an argument. And then by the chain rule, just like this one that we had du dx, so we're going to take the derivative of square root of x. By now, since we've done it, is 1 over 2 square root of x, and we rewrite it. But if you have doubts, you want to write this as x to the power of 1/2 and do it. F of x is a hyperbolic tangent of 1 plus e to the power of 2x, and the derivative of hyperbolic tangent is the hyperbolic secant squared. So we're going to write hyperbolic secant squared of what? Absolutely the same thing, the same argument. And then by the chain rule, you need the derivative of that, which is e to the power of 2x times 2, rewrite it, you're done. So pretty straightforward when it comes to hyperbolic functions as well. Find the absolute max and mean values for the given f of x equals x squared minus 1 to the power of 3 in the closed interval of minus 1 to 2. So let's remind you of a couple of things. All functions are continuous in their entire domain. So the question is, what is the domain? For polynomial functions, f of x equals a sub n x to the power of n all the way to a sub 0, and a sub n can't be 0, and it's a whole number, 0, 1, 2, 2, to infinity. The domain is all real numbers. So what you're looking at is a polynomial of degree 2 times 3, and it is continuous from negative to positive infinity, which makes it continuous in the given interval of negative 1 to 2. And because it's a closed interval, because it's continuous, now we can use the extreme value theorem. And number one, we are going to find CPs. So let's go with f prime of x. So 3 times x squared minus 1 squared times the derivative of the inside 2x. Put these two together. That is f prime. To find the CP, you have to set it equal to 0. When you set this equal to 0, this gives you x equal to 0. This gives you x squared equals 1, which is plus minus 1. So there are three answers. Also, you look at f prime dne does not exist. F prime itself is a polynomial of degree 2 times 2, 4 plus 1, 5, and it exists everywhere. So where it doesn't exist, there is no solution. There are three answers here. Now, negative 1 is one of the endpoints. The 1 is in between, 0 in between. So in essence, we are using all of it. So we are going to go with the next step, says f of a, f of b. So we're going to evaluate it at negative 1 and 2 and everything in between that is here. So we are going, those are the critical points. So plus minus 1 and 0, everything is belonging to the given interval. Let's evaluate all of this. F of a means f of negative 1. So we go into this. If you plug in negative 1, negative 1 squared is positive 1 minus 1 is 0, cubed is 0. If you plug in 0 class, it's very easy to see it's minus 1 cubed and negative 1. And if you plug in 1, 1 minus 1 is 0 becomes 0. And you plug in 2, so this is negative 1, this is 0. If you plug in 2, you get 2 squared 4 minus 1, 3 cubed, which is 27. So it's an easy evaluation. And when you do so, the maximum is 27. So absolute max is the largest value, 27 at this pair. And the absolute mean is the smallest value, -1 at this pair, 0, comma, -1. You write it in this fashion. Absolute maximum is 27 at 227. Absolute minimum is -1 at 0. Example 30. The mean value theorem. Given f of x equals 5 minus 4 over x, find all c in the interval of 1 to 4 such that the slope of a secant line equals the slope of a tangent line. So reminding you of the mean value theorem, if f is continuous in the closed interval, differentiable in the open interval of a to b, then there's a number c in the interval of a to b such that f prime is f of b minus f of a over b minus a, f of b minus f of a equals f prime of c times b minus a, the cross product. And that's exactly what this means. So here's roughly the graph of 5 minus 4 over x. Here's number 1, here's number 4, connected. So we are looking for a tangent line that is parallel and it's in between. So we are looking for this point. That's what we are looking for. All right. So with that being the case, we know this is a rational function. The domain is all real numbers except what makes the denominator 0. So so x can't be 0. And the way we write it is that f is continuous on the interval of -infinity 0, union 0 to infinity. Now, what is given? 1 to 4. Therefore, it is continuous from 1 to 4, and it makes it differentiable also. Remember, rational functions are differentiable in the entire domain. Of course, it makes them differentiable in the given domain of 1 to 4. So therefore, this works. F prime of c equals f of b, that means f of 4, minus f of a, that means f of 1. And so if I plug in 4 here, 4 over 4 becomes 1. 5 minus 1 becomes 4. If I plug in 1, this becomes 4. 5 minus 4 becomes 1. So 4 minus 1 over 4 minus 1 equals 1. So there is some point where f prime equals 1. So where is that point? Well, set f prime of x equal to that point. So what is f prime of x? You can go here. This is 0. This is minus 4 over x. It makes it 4 over x squared. Let me just, in case, I think by now everybody knows that, but you can rewrite this. F of x is 5 minus 4x to the power minus. So when you want to take the derivative, you get 0 minus 4 minus 1 x to the power minus 2, and that's how you get that. So if this is equal to 4 over x squared, on the one hand, on the other hand, must be equal to 1. It's the cross product means x squared is 4 and x is plus minus 2. So there is another point, by the way, that gives us the same thing, but between 1 and 4, only positive 2 works, okay? So there is another point at x equals -2 as well. Also reminding you of the Rolle's theorem, which is very similar to the mean value theorem. Rolle's theorem is a special case of that, which means besides the first two, we have the third criterion, f of a is also equal to f of a b, in which case f prime becomes 0. Just think about this formula. When f of b equals f of a, that means f prime is 0. We want to find the limits and reminding everyone of L'Hopital's rule. If the limit of f of x over g of x as x approaches a 0 over 0 or infinity over infinity, you can set it equal to the limit as x approaches a of f prime over g prime. So the very first thing you have to show it 0 over 0. If I plug in 1, I get ln 1. Let me just quickly show you. This is important to see that you do get ln 1 over 1 minus 1, which is 0 over 0. Otherwise, you can't use L'Hopital's rule. So according to L'Hopital's rule, this is the same as limit as x approaches 1. Now you take the derivative of the top is 1 over x, the bottom is 1, or simply this is 1 over x. If you plug in, you get 1 over 1 or simply 1. In this case, I first plug in. I want to show you, and then I'm going to erase my work. If I plug in, let me just show it here. E to the power of 0 minus e to the power of minus 0 minus 2 times 0 over 0 minus sine 0. I hope you recognize the bottom is 0 minus 0 or simply 0. The top is 1 minus 1 minus 0, which makes it 0. So it is 0 over 0. Therefore, it's justified to use L'Hopital's rule. So that means the limit as x approaches 0. Now differentiate the top, you get e to the power of x minus 1 minus plus e to the power minus x minus 2. The bottom becomes 1 minus cosine x. So we used L'Hopital's rule. That's what h represents here. Now if you plug in, you get e to the power of 0 plus e to the power of 0. That means 1 and 1, 2 minus 2 is 0. 1 minus cosine of 0 is 1. 1 minus 1 is 0. Again, 0 over 0, we can use L'Hopital's rule again. So the limit as x approaches 0. This becomes itself. This becomes minus e to the power minus x. This goes away. 1 goes away. Minus cosine. The derivative of cosine is negative sign. With this negative becomes positive sign. Plug in. If I plug in 0, I get e to the power of 0 minus e to the power of 0, which is 1 minus 1 or 0. The bottom sine of 0 is 0. Again, I can use L'Hopital's rule. This is e to the power of x. This is minus 1 minus plus e to the power of x. And the bottom is cosine x. Now, if I plug in 0, I get e to the power of 0 plus e to the power minus 0 or 0 makes no difference, cosine of 0. And I hope you see that the numerator is 1 plus 1, 2, divided by cosine of 0, which is 1, becomes 2. So very straightforward. We could use L'Hopital's rule a number of times. What happens here, just plug in. So 1 minus sine of pi over 2. Cosecant, that means 1 over sine of pi over 2. And I hope you recognize this one as 1 minus 1, because sine of pi over 2, this is pi over 2. Sine of pi over 2 is 1. 1 minus 1 is 0. Sine of pi over 2 is 1. 1 over 1 is 1. So 0 over 1 is simply 0. You don't have to do anything. It just works out. And if you don't check it, you may use L'Hopital's rule by mistake. So you have to check it. There are other indeterminate forms that we can use L'Hopital's rule as long as we turn it somehow to this format, 0 over 0, infinity over infinity. For example, indeterminate differences of infinity minus infinity, try to convert the difference into a quotient by using a common denominator or rationalizing or factoring out a common factor so that we have as indeterminate forms of 0 over 0 or infinity over infinity. For example, we want to find the limit here. If you plug in, you get cosecant of 0, which is 1 over 0, which is infinity, the 0 from the right. And cotangent is also infinity. So you get infinity minus infinity if you were plug in. But write them as cosecant becomes 1 over sine, cotangent becomes cosine minus cosine over sine. And now you write them as fractions. You can see the common denominator is sine x. The numerator is 1 minus cosine x. Now, if I plug in 0, 1 minus cosine of 0 is 1. So I get 1 minus 1 is 0. Sine of 0 is 0. I get 0 over 0. So I'm going to use L'Hopital's rule. Now, the limit as x approaches 0 from the right, 1 goes away. Minus cosine, the derivative is positive sine, and the derivative of sine is positive cosine. And so this is 0, this is 1, 0 over 1 is 0. What about this case? Again, if you plug in 1 from the right makes it ln of 0 from the right, and ln of 0, remember when you graph the ln, that goes down to negative infinity. It's minus infinity minus negative infinity. And again, is indeterminate form. So we use logarithmic properties. In this case, we can look at this one and see that we can use the quotient rule, number 6, and we're going to go from right to left. So the limit as x approaches 1 from the right, of natural log of x to the power of 7 minus 1 over x to the power of 5 minus 1. So we are using number 6, everybody. Number 6. We can interchange limit and natural log. So ln of limit of this piece and limit of this piece, if I plug in 1, I get 0 over 0. So I get ln of 0 over 0, which means this, now I can write natural log limit of, and I'm going to differentiate the top, 7 x to the power of 6, and the bottom 5 x to the power of 4. If I plug in 1, this becomes 7, this becomes 5. ln of 7 over 5 is the exact and final answer. Use Newton's method to approximate the 8th root of 500 to 8 decimal places. So we need, remember, according to that, x of n plus 1 is x of n minus f of x of n over f prime of x of n. We have to figure out what is x, what is f of x, what is f prime of x. So we let this one be x. It's important to start with this being x. If I raise this to the power of 8, this becomes 500. Bring them to the same side, and we call it f of x. So f of x is x to the power of 8 minus 500. In essence, you want the root of this function. You want the x-intercept of that function. So x gives us f of x, and f of x gives us f prime, which is 8x to the power of 7. So if we want to go with this and rewrite it in general, x of n plus 1 is x of n minus x of n to the power of 8 minus 500 over 8x to the power x of n to the power of 7. And you have to start somewhere, because this is 2, this is 3. In other words, 2 to the power of 8 is 256, and 3 to the power of 8 is 65, 61. You can start with one of those numbers. It doesn't matter which one. For example, let it be number 2. Let's start with x of 1 equals to, again, that really doesn't make any difference, because ultimately you have to show your work for a couple of works, and then the rest of them, a couple of numbers, and then you can use the program that I mentioned for a case like this. So we start with, let's say, 2. So that means if x of 1 is x of 2, x of 1 equals to 2, then x of 2 is x of 1 minus x of 1 to the power of 8 minus 500 over 8 x of 1 to the power of 7. So x of 1 is replaced by 2, everybody. So 2 minus 2 to the power of 8 minus 500 over 8 times 2 to the power of 7. See, I'm showing work step by step. Plug in and x sub 1. When x sub 1 is 2, x sub 2 is this number with a bunch of decimals. I'm showing every step of the way. Now, you may use a calculator. So y1 is your function and y2 is the derivative f prime of x. We started with number 2. So we're going to store number 2 in x. And then x minus y1 over y2, we store it in x. And we get this number. And that's what we have here again and again and again. It's important to understand how far you go when you stop. They said we wanted up to 8 decimals. You have to show your work. You can't just come up with the answer. And some students did that for the last exam. You have to show your work. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 are identical. So we want to 8 decimals. So we stop at 7. When we stop at 7, it goes up. 7 changes to 8. 7 changes to 8, and that's important to see. So every step is shown here. Use the LEP, the left endpoints, REP, the right endpoints, midpoints rule with n equals 5 to approximate this integral, reminding you of the formula, but you really have to remember the general case for Riemann sum. The area is approximated by summation of I going from 1 to n f of x of I delta x, which is f of x sub 1 times delta x all the way to the end. And delta x is b minus a over n, and so forth. So let's see what we have. Number 1, the function f of x is 1 over x. Number 2, a is 1, b is 2. Number 3, n is given as 5. So let's write all of that. Now, this function is a simple graph like this, y equals 1 over x, or f of x equals 1 over x. And you want to go from 1 to 2. So what you want is this shaded region, everybody. And we're going to blow it up, expand it so it becomes easy to understand what happens. From 1 to 2, we draw a line segment and we cut it into n. That means 5 pieces, and each one is 0.1, and then 1.2, 1.4, and so forth. So delta x is b minus a over n, or 1 over 5, or 0.2. You go with a number line. It starts with a, which happened to be 1. It ends with b, which happened to be 2. And we add the delta x of 0.2. So 1.2, 1.4, 1.6, 1.8, and so forth. For the left endpoints, remember, it's delta x, which is the same for all of them, times f of x sub 0 plus f of x sub 1, and so forth. A is x sub 0, and b is x sub n. For the left endpoints, we need f of every point here except the last one. So L5, the left endpoints, would be delta x, which is 1/5, okay, times f of 1 plus f of 1.2 plus f of 1.4 plus f of 1.6 plus f of 1.8. We do not use, for the left endpoints, we don't use the last point, which is considered right. Now, what is f of 1? 1 over x, 1 over 1. F of 1.2, 1 over 1.2. F of 1.4, 1 over 1.4. f of 1.6, 1 over 1.6, f of 1.8, 1 over 1.8. You put it into a calculator, you come up with the answer. So that's for the left endpoints. Now, for the right endpoints, let me erase my work. For the right endpoints, this is not used. Use the right endpoints. This one, this one, this one, this one, and this one. So 1 over 5. Now 1 over, you start with 1.2 and you go all the way to 2. 1 over 1.2, 1 over 1.4, and so forth. You plug it into a calculator, you come up with the answer. And again, notice, of course, this part is identical. Again, I want to emphasize what happens here. For the left endpoints, A is used, f of A. For the right endpoints, f of B is used. This is f of B, everybody. Okay, so f of A, this is f of B. Now, for the midpoints, again, let me erase my work. Just go with the midpoint here. Between 1 and 1.2 is 1.1. And then just add delta x. This becomes 1.3. Midpoints, 1.5, 1.7, 1.9. So the same thing. This function, 1 over those numbers and times delta x. So now M5, M stands for the midpoints. The integral of 1 to 2, 1 over x dx is delta x times f of those points, 1.1 plus f of 1.3 all the way 1.9. So this means 1 over 1.1. This means I'm looking at this function, okay, and so forth. So very simple. Put it into a calculator, and that is, by the way, the best approximation among all those three. I can't emphasize this enough. Use geometry to evaluate, or they might say evaluate in terms of area. Bear in mind this, we can't use it with the, we can't handle it with the techniques of calculus 1. We can use it, we can use calculus 2 to get to that, or we have to go with the area. So we have to recognize what it represents. So if we call this some function, f of x, g of x, you name it, in the interval of -3 to 3, okay, we want to look at the graph. To do that, let's call that, let's remind everybody of the circle x squared plus y squared equals r squared, so on and so forth. So these are the equations of circles, okay, centered at 0, 0, centered at h and k. So if y is that, please understand, if I raise both sides to the power of 2, and then I get y squared equals 9 minus x squared. So x squared plus 9. This is a circle centered at 0, 0 with a radius 3. However, what is this? This is a semicircle. So it's important to understand that this top portion takes this equation, y equals square root of 9 minus x squared, and the bottom takes the square minus of that. Okay, now the right side and the left side, the right side x is square root of 9 minus y squared, and the left side x is square root of 9 minus square root of 9 y squared. Okay, so with that being the case, the right side is positive and the left side is negative. So this one is positive. This one is negative. It's in the wrong spot in any event. And so this is a semicircle. So the area of a circle is pi r squared, is half of that. So it looks like that. So it's important to know we go from -3 to 3. For example, if we went from -3 to 0, would be 1/4 of a circle if it was this one. But it's the semicircle. So the graph of G is a semicircle of radius 3. So this is half of pi r squared. The radius is 3. So this is 9 pi times 1/2 results in 9 pi divided by 2.